And we're done. What did I do? Which part of it, babe? So you're talking about from here to here? Do you get this? Did you look in your identities and see that the cosecant of negative x is equal to negative cosecant of x? They're right there on that very first page. It's 586. And then once I got that, then I just pulled the top and put both pieces of the top over the entire denominator. And then reduce the things that were the same. That was it. Okay? And the last one, checkpoint 8. Okay. Now this is one where it's fairly difficult on both sides. So it may be that we wind up working on both sides, and that's okay, just not at the same time. We're going to work on one side for a while, then we'll work on the other side probably. So what am I going to do here on the left side where my fractions are? Because we always take fractions, right? Common denominator, which is 1 plus the sine of theta times 1 minus the sine of theta, right? So I'm going to have 1 minus the sine of theta times 1, so over 1 plus the sine of theta times 1 minus the sine of theta, plus 1 plus the sine of theta times the one that was already there, so I don't have to put it on there. Okay. Are we good there? All right. And so now I can combine that together, right? So I've got 1 minus the sine of theta plus 1 plus the sine of theta over, and these are the conjugate ideas when we get the difference of two squares. So that's over 1 minus the sine squared of theta. So the sine of theta in the top, those are 0 pairs, so they add out, right? So we've got 2 over 1 minus the sine squared of theta. Yes? So turning that to cosine squared is not going to help me this time, right? If I'm trying to make this side look like this side, that's not getting me anywhere, so there's no sense in doing that step. So what I may want to do now is come over here, because I got a tangent, I can turn it into a sine and a cosine, right? So let's start working on the other side. Let's just kind of leave this side alone for a minute. And so that becomes 2 plus 2 times the sine squared over the cosine squared. So what I want to do there. Maybe get a common denominator. Because this has got like that. You can think of that 2 as being up there with the sign, right? So they both need the cosine squared. So that's 2 times the cosine squared of theta over the cosine squared of theta plus 2 times the sine squared of theta over the cosine squared of theta. What can I do? Put that together. So I have 2 times the cosine squared plus 2 times the sine squared over the cosine squared. Right? Just pull it together. Pull the tops together. Since I got the same denominator, that's why I do that, right? Taylor, what's wrong? Which step? From here to here? So see, this was like, think about that 2 as being up in the numerator. See, my denominator is cosine, and this one's just 2 over 1. So I just gave it a cosine squared so that I could work with it. Okay? Because the tangent squared has to turn into the sine squared divided by the cosine squared. Whatever power is on those things that you're changing into sines and cosines, you've got to have sine and cosine be that same power. Is that better? Does that get you caught up? All right. Now, what do you see over here in this numerator that we can factor out that 2? So I'll have 2 times the cosine squared plus the sine squared, right, when I factor out that 2. Which is just 2 over the, so I could take this side and make it 2 over the cosine squared, right? And this, since that all turns into 1 because of the identity, that's just 2 over the cosine squared. Okay? You want 2 or 3 on it? 1 on each side? I can do that. All right. Do not forget that you have to do each one individually. Hey, you have to just kind of problem solve your way through it. There's not a hard, fast way that they all work. As you saw, I just did 8 different techniques. Kind of have to try and see what works. The ones that are in this homework set will work with these different 8 techniques. They didn't give you a whole bunch of extra ones on there. There may be some other algebraic manipulations that you wind up pulling in. But as far as the little techniques that we use by multiplying by the conjugate kind of idea and different things, that's going to be the same. If you will look on page 593, they give you some guidelines for verifying trig identities. Down in the blue box, they take these strategies that we just talked about and they said, okay, you can try this, and you can try this, and you can try this. Just guidelines, not hard, fast rules. There are none on these. Other than the only way you're finished is when left side and the right side are exactly the same. Once you get there, you're done. Anybody got any questions?